Lesson 19.3, Task 3. Classify sampling methods. Surveys can be analyzed to determine what type of sampling method they use. The sampling method can then be used to determine whether the sample is a representative or biased sample. You can use this information to determine whether the statistics produced by the survey can be used to make estimates about the actual parameters of the population. All right, so here you see there's a sign in the window. It says, I want to see blank here, sporting goods, electronics, clothing, bank. Text your choice 2, 1, 2, 3, 4, 5. So it says, a shopping center has empty space for stores, and the management of the shopping center performs different surveys to find what type of store the local population would prefer in that space. Evaluate the two surveys below to determine which one would provide a better statistic for estimating the population parameter. Survey 1. The management of the shopping center got 100 responses after putting up posters. 35 wanted a clothing, 28 wanted electronics, 22 wanted a bank, and 15 wanted a sporting goods store. All right, so identify the type of sample. All right, so this was a self-selected sample because people had to text in if they wanted to give their opinion. So from the poster above, you could see they text this number, text their choice, so that is a self-selected. All right, what are some possible limitations of this sampling method? All right, so the shopping center is overcrowded. The sampling method limits participation to texting. That definitely would be one because maybe not everyone is able to text or knows how to do that. It's like some of the older population I know still may not do that. So this would definitely be self-selected. The sampling method is too robust. People who are too busy in the moment may forget to respond later once the poster is no longer in front of them. That also could be true. If they're too busy at the time and then they don't see it again, then they may forget. And the survey's too long. Probably the survey's not very long. It's one question, right? So, all right. Now it says determine whether the sample is representative. This may not be representative of the population as a whole. It includes only those who decided to take the action of texting the number with their opinions, but it might be that others who would spend money there prefer other options. All right, survey 2. A survey of 10 randomly selected adults from each of 10 local neighborhoods found that 43 wanted clothing store, 23 electronic, 21 sporting goods, and 13 a bank. Of these 4 types of stores, which would you advise management to bring in? Well, this one says 43 wants clothing. I would say a clothing store because that's what the most people preferred. Identify the type of sample. This is a stratified sample, and it says determine whether the sample is representative. All right, so this is likely representative of the population because it includes randomly selected people from several different groups likely to go to the shopping center. All right, so remember stratified is when they're like put into groups and you may do samples from each group because they chose 10 people from each of different neighborhoods or so many people from each 10 randomly selected adults, each from 10 neighborhoods, then they're sampling 100 people still, but it's from a good variety of people from different neighborhoods, and it's random, so that would make that a good choice. It says select the better survey. Okay, survey 2 is the survey that the management should use. It is more likely to be representative of the population as a whole, and so its statistics will provide better estimates for the population parameters. All right, that's all for task 3. If you have any questions. Lesson 19.3, task 4. Make predictions from a random sample. You can use data from a random sample to make predictions about the corresponding population. Numerical data represent quantities or observations that can be measured, such as number of siblings or total rainfall. Categorical data represent attributes that can be sorted into groups or categories, such as animal species or hair color. While the mean is useful for summarizing numerical data, you can use a proportion to describe categorical data. The proportion of individuals in a category is the ratio of the number of individuals in the category to the total number of individuals. A proportion calculated from a sample can be used to draw conclusions about a population. A health center in a town with 15,000 adults surveyed a random sample of 30 adults from the town about the vegetables they ate during the past week. The table shows the types of vegetables people reported eating, the total number of servings of each vegetable eaten by the group, and the number of calories per serving. All right, so here's the table of vegetables. You see there's asparagus, bell peppers, broccoli, carrots, cauliflower, celery, corn, spinach, and zucchini. It also has the number of servings, and it has calories per serving. All right, so find the proportion of vegetable servings eaten that were corn servings. So you would do corn out of total servings. So you can see here in the table that 8, and then total servings would come by adding up all the numbers of servings together. So that's what they did. They took 8 and then divided that by the sum of all the servings here. So 8 over 56 can be reduced to 1/7. So about 14.3% were corn. All right, so what data in the table are categorical? What data are numerical? All right, basically, numerical obviously is just numbers. So we can look down through here and we know that both the number of servings and calories both are numerical, and the categorical would be the types of vegetables. So that's just identifying which category it falls under. Estimate how many corn servings were eaten by all adults in the town during the past week. So first estimate the total number of X of vegetable servings eaten by the town's adults in the past week. So they're going to do total servings for the sample. We know the total servings were 56. That's already been added up. That's divided by 30 because that's your sample size. If you remember up here, it said there's 15,000 adults surveyed, a random sample of 30 adults from the town. So 30 adults is the number of the sample. 15,000 adults is the total number for the whole population. All right, so the 56 over 30 equals total servings for the population. That's what we're trying to find. So that's X, size of the population. Again, that is the 15,000. So this is a proportion. So you cross multiply. You've been doing this since middle school, hopefully. And so you're just cross multiply and then solve for X. So that's going to give us 28,000 servings. That's total servings for all your vegetables. So how do we figure out how many of those were of corn? So it says, then multiply the result by the sample proportion of servings that were corn. We know that 1/7 of the servings are corn. So 1/7 of 28,000 is about 4,000. All right, why is this a good estimate for the number of servings of corn eaten by the town's adults in the past week? The sample portion 1/7 tells you that 1/7 of the vegetable servings eaten in the past week by the people sampled were corn. Because the sample was randomly selected, it is reasonable to conclude that about 1/7 of the estimated 28,000 vegetable servings eaten in the past week by all adults in the town are corn. So the estimated number of corn servings eaten by all the town's adults is about 4,000. So it says about 4,000 servings of corn were eaten by the town's adults during the past week. All right, that's all for task 4. If you have any questions, let me know.